So my topic is MVT, the mean value theorem, and my first equation will be f of x is equal to 1 plus cubic root of x minus 1, and our points will be from 2 to 9. So first thing we're going to do is find our hypothesis. For step 1, we got to find where f of x is continuous on. F of x is continuous on. And for this particular equation, this one is continuous from negative infinity to infinity. And this is because it is a root function. It is a roots function. And so this would mean that this equation is also continuous from 2 to 9. And for step 2, we got to find where f of x is differentiable on. And for this equation, this one is differentiable from negative infinity to 1, union with 1 to infinity. And this is because it's also a root function. And this would mean that it is also differentiable from 2 to 9. And so our conclusion would be our f prime of c is equal to f9 minus f2 over 9 minus 2. So here we have our f prime of c. And so when we plug in our 9 and our 2 back into our equation, we get that this is equal to 1 over 7. And so now that we have that, we gotta find our f prime of x. And so when we find our f prime of x, actually, the first thing I have to do is rewrite our equation. So we get 1 plus, and so when we have the cubic root of x minus 1, this can be rewritten as x minus 1 to the power of 1 over 3. And so when we find the derivative of this one, we get that. So derivative of 1 is 0. So I won't write that, but and for the derivative of this one, you bring the 1/3 down, and exponent x minus 1, and you subtract 1. So this would be 1 over 3 minus technically 3 over 3, which is equal to negative 2 over 3. So you get negative 2 over 3. And so with this, you can rewrite this as that 1 over 3, and then or 1 over 3 parentheses x minus 1 to the power of 2 over 3. And from there you can rewrite this again as 1 over 3 square root or cubic root of x minus 1 squared. So now we have our f prime at x. So now we just put this equal to 1 over 7, because that was our f prime of c. And so now we just solve this for x. So first thing we should do is rewrite this equation once again. So we gotta pretty much unsimplify it, I guess you'd say. So we do 1 over 3 parentheses x minus 1 to the power of 2 over 3 to 2 over 7. From there, multiply this by 3 over 1, 3 over 1. These cancel out, so we get 1 over parentheses x minus 1 to the power of 2 over 3 is equal to 3 over 7. From there, multiply this by x minus 1 to the power of 2 over 3 over 1, I guess. And then same thing you do to that side, you do to this side. So we do x minus 1 power of 2 over 3 over 1. These are going to cancel out. We get 1 is equal to 3 over 7 times x minus 1 power of 2 over 3. So we have that. Multiply this, 7 over 3, 7 over 3. These right here cancel out. So we get 7 over 3 is equal to x minus 1 to the power of 2 over 3. Multiply this whole side by exponent of 3 over 2. Same thing to that side, you gotta do this side, so 3 over 2. So you get 7 over 3 is the power of 3 over 2 is equal to x minus 1. And from there, you can add 1. Okay, you would add 1 there, so add 1, you get 1 plus 7 over 3, it's the power of 3 over 2 is equal to x. And from there, we can rewrite it once again. So it would be 1 plus this would be square root 7 over 3 to the power of 3 is equal to x. So that would mean that our c is equal to 1 plus square root of 7 over 3 to the power of 3. And that is our c. So for our second equation, we have 1 over 2 x to the power of 3 minus 2x plus 4. And the points will be from 1 to 2. So same thing as last time. We gotta find the hypothesis. For step 1, gotta find where it's continuous on. And for this equation, if x is continuous on negative infinity to infinity, and this is because it is a polynomial. And so this would mean that the points from the points from 1 to 2 is also continuous. And for step 2, we gotta find where f of x is differentiable on. And same thing, it is supposed to be brackets. It's parentheses, so it is differentiable from negative infinity to infinity. Same thing, because it is a polynomial. It is a polynomial. And same thing as the top. So this is differentiable on 1 to 2. And so conclusion would be f prime of c is equal to f of 2 minus f of 1 over 2 minus 1. And this, when I did the calculations, is equal to 0.375. So now we gotta find our derivative of the original equation. So I'm just gonna write this equation down here again, so it's easy to see. So this is our original equation right here. We find the derivative of this one. Bring the 3 to the front. We get 3 over 2 x squared minus 2. And so from there, we can just do. Actually, I'm gonna change the 3 over 2 to 1.5. So it's easier because I'm dealing with decimals. So I'm just gonna do that. X squared minus 2 is equal to, or bring down f prime c over here. So it should be 0.375. From here we just add 2 to there, add 2. So 1.5 x squared is equal to 2.375. We divide this by 1.5. We get x squared is equal to, and when I did the math on this one, I got 1.583 repeating. And so when we do this, we get x is equal to plus or minus square root of 1.583 repeating. And so this would mean that our c is equal to plus or minus 1.583 repeating.